Ahad, how did your exam go? It was good, huh? So were you able to manage chapter 2 there? Because chapter 2 few portion was left. And Rifat and Dream, your exams are over now, your UTs which were going.
Yeah,
Ma'am, it's
Yes, Rifat.
my physics exam got over.
Physics got over. Otherwise, your exams are still going on.
Yes.
Alright. And Reem, what about you?
my physics is over.
And UTs are still going right now.
Yeah.
Alright. So, see, first chapter has been completed. 2 to 3 questions came from chapter 2. That derivation of point charge came. Yes, that's why I made you do that specially, because that often comes in exam. Okay, then you were able to manage. That's good. See, you were having a subjective test today, but I didn't announce it in the last class because you people were busy with your exam, and at the end only Fahad stayed in the class. So chapter 1 is over. Chapter 1 has been done a long time back. So let's have a short subjective test within the class itself. Means of 30 minutes duration, half an hour duration. In the class only we'll be having the test. So chapter 1 test will be there. So on Tuesday. So do you people agree with it? Tuesday is fine for you all? It had to be conducted
ma'am.
this week. All right. Okay. So we had started with potential. So potential due to point charge. So this derivation must have come, no? Fahad, this derivation. So potential due to point charges KQ by R. So how to use this in numericals? How to utilize this in numericals, that we'll see. So let's do it in the, you wrote it well, no? Okay. Are you people added in the group? Reem, Fahad, Rifat.
Yes.
WhatsApp group you're added there?
Yeah.
Alright, then it's fine. Okay, so let's do it with the help of a question. Madiha, your UTs are over by now? Or some papers are still left?
My last exam is on Sunday in the physics.
Sunday. Okay. Last exam is left. So yes, this is the question. Let's discuss it. See, potential, you have to calculate potential at point O. If you people remember, I have told you that potential is what? Potential is a scalar quantity. So we are not supposed to take the directions. We'll directly straight away write it. And since we are not considering the directions and it's a scalar quantity, what we'll be requiring? We'll be putting the signs. If it's a negative charge, we'll be writing, we'll subtract. If it's a positive charge, then we'll put a plus sign and add it. Now at the center, see, at the center you have to calculate. So at the center, if you have to calculate, it means you have to know this separation between A point and O point, between O point and C point, between D point and O point, between B point and O point. Obviously these separations, then only you'll be able to calculate the potential at the center. So can anyone tell any method to calculate what will be A? Or just calculate and tell me this much. All of you try it and send your answers in the chat box. All of you try this at least. What will be AO? Side of the square is A. So what will be the half of its diagonal? See, if you see, did anyone get the answer? Half of the diagonal of a square. See, just remember it. If you have the diagonal, if you have the side as A, no, you have to find out, you have to calculate the half of the diagonal of square. Learn it as it will always be A by root. Now, how? We'll see it. Because this will be utilized often. A by root 2, this has to be calculated and it will be utilized often. So, you have to remember, half of diagonal is A by root 2. Yes, Mati, right. It is half of diagonal is A by root 2. Now, for those who are not able to remember this, there's always a method to calculate it. If you see this triangle, this is A side, this complete side is what? This is complete side is A. So A is there, and what will be the hypotenuse of the triangle? Hypotenuse means AC. So AC will be what? AC will be under root A square plus A square using Pythagoras theorem. So what does it become? It becomes root 2A. So whole diagonal is root 2A. So half of the diagonal will be what? Means AO, which is equal to BO, which is equal to CO, which is equal to DO. All these will be equal to root 2A divided by 2. So if you multiply and divide it by root 2 means to rationalize it. Rational numbers you must have studied. So this becomes A by root 2. Otherwise, you can simply directly remember it that if the side of the square is A, then the diagonal of the square is given by A, half of diagonal is given by A by root 2. Now we know the separation and we'll be able to easily calculate the potential at the center O. See, potential at the center O will be VA plus VB plus VC plus VD because of all the charges. Remember, the general formula is what? KQ divided by R. You have to place it here. KQ by R. In KQ by R, you have to put all the values. So first one, let me tell you. Let's take VA. K will be there. Then Q, what is the charge at point A? Plus E. So it will be KE. And what is the separation? A by root 2. So KE divided by A by root 2. That becomes VA. Charge is E. See, VA will be what? K. For Q, what I have? Q, I have plus E as the charge. What is the separation? A by root 2. Fahad, you tell me what will be VB. Look at the figure and tell me what will be VB. Charge is this. Separation is A by root 2. This separation. What will be VB? Fahad. K minus E by root 2. I think A you got missed. A by root 2. That must be a typing error, Yes, A by root 2. Good. We will have to add this negative sign since it's a negative charge. So, rightly said by Fahad, this will be K multiplied by minus E divided by A by root 2. All right, now plus VC. VC Reem, you tell me. Reem, try VC.
K plus E by A by root 2.
What is the charge? See, everything is getting multiplied. So K is the constant. Charge is what at point C?
Plus E.
See, where is this point C? This is point C. What is the charge over here?
2E plus 2.
Plus 2E divided by A by root 2. Clear?
Yes, ma'am.
This will be K, charge is 2E divided by A by root 2. Rifat, can you try for VD? Last one is there. This is D point.
Minus 2e by
Minus 2. So K will be there first, which gets multiplied by the charge. Charge is minus 2E divided by?
beta.
Yes, Rifat? A by root 2. A by root 2, because that separation is A by root 2. Good. So this will be what? This will be K multiplied by minus 2E divided by A by root 2. Now we just have to solve this. See, K root 2 will go in the numerator. For all it is A by root 2. Reason is that, Fahad, see here. If you look at the square, diagonals of the square are equal. So that's why it will always be equal. If you apply the property of square, all these separation from to this point O, because we have to calculate at this point O, no? So at this point, all the separation is same. That's why we are taking directly A by root 2. If it would have been different, like we'll see, point E is also mentioned to us. There we'll see this sides will change, the separations will change. So root 2 will go up, root 2 K E by A can be taken as common. What is left? If we take this common, here it is plus 1, here it is minus 1, here it is left what? Plus 2, and here it is left as minus 2. So see, minus 1 gets cancelled, plus 2 gets cancelled, or you can directly cancel these also. So what you get? Root 2 KE by A multiplied by this whole becomes 0. So your potential at the center will also be 0. This will be the answer for the first part. Now for the second part, work done at here is just one more thing. For all those who weren't present in the last class, we had discussed that work done can also be written as charge multiplied by the change in potential. So if potential difference is 0, like in at the center O, if potential is coming 0, then work done will also be 0. So work done first is 0. But what is the question is saying? Question is saying work done in carrying charge from O to point E. So work done at O first you have to calculate, then work done at E you have to calculate. Whatever is the difference, that is the work done in carrying the charge from O to E. This is the method to solve. If you get any other point, for example, if you get a point as A, calculate the work done in carrying proton from A to C. Then calculate the work done at point A, calculate the work done at point C. Whatever is the difference between them, that gives you the total work done. So here also, work done at point O is simple. It will directly be 0 because potential is 0. But here, the potential at E is something. We have to calculate the potential at E now. E is this point. So I'll redraw it. I'll redraw this for the second part. That was for the first part. For the second part, you can see. This is the square that we are having. See, I'm drawing a bigger square. Let me just draw point E. This was point E. And this is point E now. A, B, C, D. Rest of the things are there in the square. Now, this separation is A by 2. This separation is A by 2. this is A, this is A, and this is A. This was given us to us, no? And why have we taken this? Because we will be also needing point A also. Charge is placed at point A as well. Now, separation of all these are given from E. But do you see AE is not there? AE is not there. So we have to calculate AE. And whatever will be AE, that will be equal to DE. So AE, that will be equal to DE. It will be under root. Just use Pythagoras theorem. Pythagoras theorem says what? Square of perpendicular plus square of base gives you the square of hypotenuse. So that's why we have taken under root. So this becomes 4a square plus a square becomes 5a square divided by 4 under root. So a by 2 will be common and root 5 will be left. This will be AE. So this is coming how much? Root 5 a by 2, and this separation is also root 5 a by 2. Now we have the separations. Now we can calculate the potential, and then we can multiply it by the charge and get the work done. And the difference between both the work done will give us the total work done. This is the step that you always have to follow whenever you are calculating. So now check. At point E we are calculating, no, VE. So this will be VA again plus VB plus VC plus VD. So first I'm telling. First A, C. Let me write the charges. This was plus E at A. It was minus E. This was plus 2E, and at D it is minus 2. These are 4 charges. So VA will be what? What is the formula that I told you? KQ divided by R. So Q is E divided by R. See, separation between A and E is what? Root 5A by 2. So VA will be what? It will be root 5A by 2 in the denominator. Now this will be K, charge will be E. Separation is what? Root 5A by 2. This will be VA now. A by 2 will be given in the question. This is a part of question. Yes, Fahad, you are right. Why I have taken this point E as A by 2 means at the middle of this, because this is mentioned. This was mentioned in the question. If you see the question, whatever is the main question, I think this has come in your board exam already. So if you see the main question, there it has mentioned that point E lies at the center of BC. So that will be mentioned to you. If BE is A by 3 and CE is something else, that will be mentioned to you. Here in this question specifically, we are taking A by 2 because it is given. Whatever will be the separation, that you have to consider. Madiha, can you tell VB? Madiha is there in the class?
Yes, ma'am, I'm there.
Yes, Madiha. VB. For point E. KQ by R is the general formula. Now put everything in there. K will be there. Charge will be here. The charge will be what? A root 5 by 2. I'm explaining that again. Yes, Madiha. What is the charge at point B?
Minus C.
Minus C. So K multiplied by minus C and divided by what is the separation between E and B?
A by root 2.
A by
2.
A
Sorry.
by 2. A by 2. See, this is the separation right now we are talking. So VB will be what? K multiplied by minus E divided by the separation, that is A by 2. Fahad was asking about how did this root 5A by 2 came. See, this triangle is
ma'am,
again a right angle triangle. Yes,
Is
Madiha?
VB 2 minus 2 E K by A?
Not 2. VB 2 minus 2K E by A. Yes. Minus 2K E
Yes.
by A. Yes, because A by 2 will go in the numerator. That will be correct. Yes. Fahad, see. This side is A, this is A by 2. Means this is your perpendicular, this is your base, and this is your hypotenuse. According to Pythagoras theorem, Hypotenuse square is given by perpendicular square plus square of base. So hypotenuse will be what? Under root of perpendicular square plus base square. Perpendicular here is a, base is a by 2. So it will be a square plus a square by 4. So if you take the LCM, this becomes 4a square plus a square divided by 4. And 4a square plus a square is what? That is 5a square. So this becomes root 5a square by 4. So a square can be written as a, under root 4 can be written as 2, and root 5 we are leaving it. 4 from where? This 4. If you square a by 2, what will it be? A square by 4 only, no? Here, we have to square them. A square, squaring this. Okay. That is how you got root 5a by 2. So VA we have calculated, VB we have calculated. Reem, you tell us VC. This is point C. We are calculating at this point E. So KQ by R is the formula. Again, I am repeating.
K plus 2E by A by 2.
See. Whenever you say no plus 2E, it seems like you are adding it. Always
Multiplied
remember you are
by-
multiplying. Yes. So
Yes.
K multiplied by plus 2E divided by
A by 2.
perfectly. Yes, this is how we'll write it for BC. So this will be what? This will be K. This will be 2E divided by A by 2. Last. Fahad, you try VD. Last one, VD. See, this is D. This is the charge. This is point E. And this is the separation between D and E. K into minus 2E divided by not A square. K multiplied by minus 2E is correct, Fahad. But what is the separation between D and E point? What is this separation? Root 5 by 2 whole thing. Root 5, this separation is root 5 by 2. So that you will take whatever is the separation. All right. So VD will be what? This will become K multiplied by minus 2E divided by the separation that was root 25A by 2. So from here we can say what? 2K E can also be taken common and A can also be taken common. So what will be left here? 1 by root 5 will be left. From here, minus 1 will be left. From here, 2K, so 2 will be left, plus 2 will be left. From here, 1, 2, yani minus 2 by root 5. Minus 2 by root 5. This all will be left if we take this common. So 1 by root 5 minus 2 by root 5 is what? Minus 1 by root 5. This is 2ke by a. This becomes, and 2 minus 1 is 1. So this is 1 by minus 1 by root. This is your potential at E. What is work done? Work done is charge multiplied by potential. The charge is a proton, and in all of your first classes I've mentioned you what is the charge on a proton. A by 2 we take common. Yes, A by 2 we have taken common. That's why this 2 is going in the numerator. A by 2 is there in the denominator, no? So that's why this 2 is going in the numerator. So A by 2 we have taken common. If you people remember, the charge on the proton and charge on electron both are same. It's just that we put different signs. I've told you all people in your first classes. So charge on the proton will be what? It will be E, electronic charge, multiplied by the potential. What is the potential? Potential at point E. So that becomes 2K E square, because E is getting multiplied by the C, A 1 minus 1 by root 5. So this is work done at what? Work done at point E. And work done at point O was what? 0, because potential was 0. Since potential was 0, work done also became 0. So what is the change in work done? Change in work done, this is WE minus WO this will be simply, what was the answer? 2ke square by a, 1 minus 1 by root 5. All right, this is how we do questions whenever you are given for calculation of potential and you have to calculate the work done as well. All right, so note down this. And Madhi, I think you joined late. You have a subjective test within the class itself of the first chapter, electric charges and field. So whatever we have, a very short subjective test will be there in front of me only. You will be having the test. So on Tuesday. All right, Madhya, fine by you?
Okay, ma'am.
No, a by root 2 won't be there in the question. A by root 2 we have calculated because this side was a and this side was a. So under root a square plus a square gave us root 2a. So root 2a is the diagonal, half of it gives a by root 2. Yes, Parth. See this part, no. This is a rationalization of numbers. Whenever you have root in the numerator, no. So you multiply and divide it by the same number. So if I multiply it by root 2 and divide it by root 2, I'll still get 1. Both of them will cancel. If I divide the numerator and denominator with the same number, that won't affect the answer. And remember, root 2 multiplied by root 2 gives you 2. So this will be what? This becomes, just to rationalize this number, if I multiply root 2 with root 2, this gives 2. Here a is left. In the denominator, what is left? 2 root a. So 2 gets cancelled and a by root 2 is left. Now clear, Fahad? Done? So by now you all must have completed it. Writing portion, no? Done? Alright, done.
Done, ma'am.
Okay. So this is about work done and potential whenever you have to calculate either of the two. Now we had already studied one more thing. Based on this, numericals will come this way only, the way we have done Fahad. In this way only. It can give you a triangle. On the triangle, there must be some charges located the way. This is the way we have done this numerical. No. Other questions will be in this form only. It can give you a straight line. Two charges are there. So KQ by R directly. Then you can get a triangle in the form of square. We already did. So the most difficult one is square only. That's why I discussed square. Other, if you are able to understand this one, you'll be able to manage. Now this was due to a single charge KQ by R. What if you have a dipole? Then you won't be able to use KQ by R. So you have a separate formula for potential due to dipole, electric potential due to dipole. For that, let's consider a dipole first. This is charge plus Q, this is charge minus Q. If you, all those who have forgotten what is meant by a dipole is basically two charges which have the same magnitude but have the opposite sign. So if one is positive, other one will be negative. Now I'm just taking a general point. P point I have taken. This is a general point. Neither it is situated at the equatorial line nor it is situated at the axial line. I have just taken a random point. Let's mark the separation between these points. Let's say this one is what? This one is R1. And this one is R2. Now, for the calculation of this, for finding out what is the potential due to dipole, first let me mark a line through the midpoint of this. Through the midpoint of this. Separation of dipole, remember we always used to take it as 2a. So this will be what? If this is 2a, this part will be a and this part will be a. Let's say this is theta. Now in order to calculate the dipole, we'll just draw perpendiculars on it. One perpendicular this side, one perpendicular this side. Let's name this. This is A, this is P, this is B. AB, make this point at the intersection as O, make this as C, this as D. So we have all the points located. And this length from point P to the center O, this is smaller. Now we have to calculate the potential at point P. You have to find out the potential at point P. At point P. So V will be equal to what? Two charges are there, plus Q is there, minus Q is there. Separation is R1, separation is R2. For point charge, we know this will be what? This will be K First charge is Q divided by R1 minus what? K Q divided by R2. Why minus? Because this charge is minus Q. This charge is the negative charge. Minus Q charge is there. Minus Q. From here you can take KQ common. If you take KQ common, what will be left? Here you will be left with 1 by R1 by 1 by R2. So we just have to find out the values of R1 and R2 and put it in this. Now if you look here in this is point P, this is point A. If you see this PA, this is almost equal to this PC. PA is almost equal to PC. We have drawn it in such manner that because these two sides were not getting equal, that's why we had to extend this and drop a perpendicular over here. So both of these are almost equal to each other. PA is what? PA is composed of, not PA, PC is what? PC is composed of PO plus OC. This is one of your derivations. This what I am discussing right now. This is one of your derivations. So this will be what? This will be PO plus OC. PO plus OC. Now what is PO? PO is small r. And what is PA? PA is R1. So this will be what? PA is R1. PO is small r. And this is plus OC. Now, OC's value we don't know. OC's value also we should know. If you see this triangle, if this is theta, this angle, this is theta. So in this triangle ACO, here, if you look at this triangle, if you write cos theta, what is cos theta? Cos theta is always base by perpendicular, base by hypotenuse. So this will be what? This will be OC divided by, this is your base 2A, this is your base OC, which is unknown to us, which we are calculating. OC we are calculating, divided by, this will be A. So OC becomes what? This becomes A cos theta. How A cos theta? Because AO is small a. Now we can write the value of R1. R1 is R plus A cos theta. Similarly, if I let me write it here because the figure is here. If I talk about these two sides, these two shorter sides, PD and PB, they both can be equal. No, they can. These two sides can almost be equal. That's why we have dropped this perpendicular to get a side which is almost equal to PB. So PB is almost equal to PD. So PB can be written as what? PD is what? If you subtract from PC, if you subtract CD, what will you get? If you subtract from, this is the whole length. This is comprising of what? This is comprising of P point. This is comprising of D point. This is comprising of O point. And this is C point. So in this will be what? This will be PO minus OD simply. If you subtract PO minus OD from this, you will get PD. Now PB is what? PB is R2. PO is what? PO is small r minus OD. Again, in this triangle. In triangle what? Now you have to focus on this shorter triangle. This triangle. This is a derivation. In triangle, what is the name? BDO. Again, if you write cos theta. If you look at this triangle and write cos theta. So cos theta will be what? Cos theta will be, it will be OD by OB. This will be cos theta. So OD is unknown. OB is again small a. So OD becomes what? OD will be written as A cos theta again. So R2 is what? R2 will be R minus A cos theta. Now you have values of R1 and R2 with you. R1 is what? R1 is R plus A cos theta. R2 is what? R2 is R minus A cos theta. What was the main formula that we were discussing? V is equal to KQ. 1 by R1. That becomes R plus A cos theta minus 1 by R2. This becomes A minus A cos theta on putting the values of these. So we just have to solve this now. Take the LCM of it. This becomes R minus A cos theta minus R minus A cos theta divided by r plus a cos theta multiplied by r minus a cos theta. This is your this bracket. So r gets cancelled. V what? V will be equal to 2 minus 2 a cos theta. Minus a cos theta becomes minus 2 a cos theta. And if you look at the lower part, this is a plus b multiplied by a minus b, which is identity is a square minus b square. So this becomes what? This is k q minus 2a cos theta. This is r square minus a square cos square theta. From here, if you are able to remember this, q multiplied by 2a. Are you able to remember what was q multiplied by 2a? Anyone? This q multiplied by 2a was what? Yes?
Dipole moment.
Dipole moment. Yes, P, Fahad, yes. This was dipole moment, P. So the formula, final formula of potential becomes what? Minus K P cos theta divided by R square minus A square cos square theta. So in case of potential, the formula of dipole is this. Now, axial line and equatorial line are situated here as well. You have axial line and equatorial line case as well. That we'll see, but let us reduce it in terms of ideal dipole approximation. In case of ideal dipole approximation, if you people remember, I've told you that the size of dipole becomes very small. That is, A becomes very, very smaller than R. So V becomes what? V will directly be equal to Kp cos theta divided by R square. This will be the formula. Now, from here you can get the values of axial and equatorial line. How? This is very simple now. If you know the general formula, this is the general formula. For axial line, the angle between, we have seen already what the angle between the charges means the dipole, wherever the dipole's direction is, and the potential that we are calculating. That angle is what? That angle is simply 0. Means if this is minus q, this is plus q. At this point we are calculating. Let's say this is the separation, small r is there. This is center O. Then at the center, theta is what? Theta is 0 degree. Whereas in case of equatorial line, if you have equatorial line, this was axial, this is equatorial. If this is plus q, this is minus q. At this point we are calculating. So this angle becomes what? This becomes 90 degrees. So theta is 90 degrees. Now you know the general formula. Put in the values of it. If you put theta as 0 degree, this becomes minus kp cos 0 is 1 divided by r square. This is the formula of potential at the axial line. Equatorial line, cos theta 90 means 0. So there is no potential at the equatorial line. Clear? Is this derivation clear to all of you? Okay, do one thing, start writing it down. At whichever point you are not able to understand, just ask. This is the potential due to dipole moment. Yes, PA, this PA is almost equal to PC, this. Okay, Madhya, fine. r minus a cos theta from here. See, value of OD is what? OD is a cos theta. And R2 was r minus OD. So this became R2 is equal to r minus OD, and OD is what? OD is a cos theta. So it is given that two charges are there and they are placed at 0, 0 minus A. It means on the z-axis plus q is located at minus a. So this separation, this will be a because this point is 0, 0, minus a, and this point will also be a because this point is what, 0, 0, plus a. This is the z-axis, negative z-axis and the positive z-axis. You have to calculate the potential at what point O, 0, 0, z. See, this is again potential of dipole. So for the first part, what was the formula? Kp cos theta by r square minus a square cos square theta. This was the formula that we had seen. Now theta will be 0 degrees by direction of dipole. This is the direction of dipole. Dipole direction is this. And r is what? R here it is a. So v at a becomes, this simply becomes cos theta will be 0. It will be kp divided by z square minus a square, because cos square theta will also be 0, will also be 1, and here it also will be 1, and r is equal to z. So this will be the answer for the first part. And second part says what? Potential at 0 comma x comma 0 comma 0. See, x comma 0 comma 0 comma means what? This point is here. Why did I take theta as 0? Because this point that I am calculating at, a point which is given as 0, 0, z, let's say this is a point. So a point is located on the axis only, no? This is the axis. That's why this is the case of axial line. But if I write B point, which is located here at x, 0, 0, can you see? All the three axes are perpendicular to each other. All the three axes are always perpendicular to each other. It means this point is lying at equatorial of it. So for equatorial, what did we study? For equatorial, we have studied potential is 0. So BB, it will be 0 because it is equatorial. All right, note down this numerical as well. Fahad, this is a type of numerical only. This is a numerical only that we have discussed in this. It's just that it can be different by, it can give you any value of z. You can get a different value of z. This method will remain the same. That's why we have done it this numerical on dipole. And the rest of the numericals, you will get it in the form of assignment on WhatsApp or on the Learnivio website. Okay, Fahad? So written both of you, Fahad and Rifat, written. And what about you, Rifat? Written, no? Okay, so I'm stopping here. Then from the next class, we'll discuss the relation between electric field and potential, and you will be having a test as well. That theta is at at axial point. Theta is 0 degree at axial point, and for